just built the largest AMD GPU cluster in the world. They have 8,192 MI 325X GPUs. And I want to share an interview that one of um, TensorWave just did that goes in depth about the differences between NVIDIA and AMD. And I'll mainly share what I'll mainly share the parts about that he goes in depth about AMD products and how AMD is poised to do extremely well over the coming years in open source world, open source AI world. And then I'll share with you yesterday's All In Summit clip with Lisa Su, who had made a surprise appearance with the All In team, which is pretty awesome. So yeah, so let's start with the video here. This is TensorWave's AI's Next Chapter, AMD's big opportunity with Gregory Diamos. And we'll just start off here, and I'll probably skip parts of it.
The origins of CUDA were always to go beyond CUDA. That was the whole point of it.
All right, welcome to the Beyond CUDA podcast. I'm your host, Jeff Tatarchuk, co-founder of TensorWave, the AMD GPU Cloud. Today's guest we have on our show is Greg Diamos. He has his PhD in electrical engineering from Georgia Tech. He was involved in the early days of CUDA, working on NVIDIA's Volta GPU, and a key force behind scaling deep learning at Baidu. He helped launch MLPerf, which is the industry standard benchmark for ML systems. He's worked across the board from leading AI startups to the big three chip giants, NVIDIA, Intel, and AMD. And he's now focused on an exciting open source project called Scalar LM, which we'll dive into later in the show. But Greg, great to see you, man. Thanks for joining us.
Great to be here, Jeff. Thanks for having me.
Yeah, I'd like to, man, you have an amazing journey. As I was going through your history, I'd like to start from the very beginning. Where did your interest in electrical engineering come from?
Yeah, it actually is a strange story now that I go back and think about it. It started when I was 10. So
I'm going to pause there and let's go a little bit forward to where they start talking about AMD.
So I think the thing I like the most about AMD is that they listen to feedback. Even early when we were at Baidu, they would come and say, oh, these are the labs who are building deep learning. What do you need to support? And it's a lot of work. I think AMD's had thousands of engineers working on that since 2018. And I don't want to diminish it, but it's like eventually you get it. Like eventually you fill in all of these pieces.
Yeah, and they have been. I've seen AMD has done a lot of work to hire engineers and put resources towards this. And it's interesting to me when I talk to various folks that have been involved at NVIDIA and AMD on the software architecture side of things, they all have varying opinions as to which direction they should go down that will actually crack this code and create a sustainable software stack. So what's your thought on it? What do you see as the opportunity on the AMD side when it comes to the software architecture that maybe AMD isn't paying attention to right now that they could spend a little bit more time focusing on to help close the gap on the software side?
Definitely. One thing I'd start with is I think more people should be using AMD. I think not at the very large scale yet, but at the small and medium scale. And the small and medium scale is pretty big, like the MI 300, has 200 gigabytes of HBM. It has a huge capacity to run you could run 70 billion parameter LLMs on one GPU. So the small end, maybe not that small, but the small end is pretty stable. If you just wanted to spin up a container, spin up an inference service, download Hugging Face transformers, run it on MI 300, it'll probably just work and it'll get good performance. So that's something that you cannot say about most accelerators. And that was the thing a few years ago when I started poking into this. They got me really.
So let's pause there because this is really part of the AMD thesis. A lot of AMD investors are invested in the company because AMD differentiates itself with its ability to really cater towards the individual AI user, as well as the smaller companies that are building AI products. And this is a PhD here. He's talking about how you can run an LLM with 70 billion parameters on one AMD GPU. So it's kind of like a plug and play. And the reason that's important is because AMD, they're obviously going to compete with Nvidia, but they're also not necessarily competing with Nvidia everywhere. They're really going after the edge market. They're going after the little guy, the startups, the smaller companies, drones. There's a huge edge AI market as well as the physical AI market that's going to require their products. And because AMD gives you more for less, and that the less part means cost, and with more power efficiency, it's really quite attractive to those who can't spend the big bucks on the NVIDIA chips. So, anyways, I'll let him continue.
Excited about AMD, that they've made that much progress on the software stack. Even getting to that level is really hard. But you asked about what's a missing piece. I think AMD's made a lot of progress on scale out, so on running on larger scale than that, because of course, generative AI is so computationally intensive. These are the biggest models we've ever seen in the kind of history of machine learning. These are so computationally intensive. These transformers for things like GPT-4, Claude, Llama, these are just enormously computationally intensive algorithms. So you want to run them on a really large scale system. If you have a significant number of users, or if you want to train them, they need a really big system, not just one GPU. You need to start thinking about thousands or hundreds of thousands of GPUs. So getting scale out is maybe the next frontier for AMD. And they made a lot of progress over the last few years in inference. So you can look at the MLPerf results. Their inference servers on MI300 or 325 compared to H100 or H200 are effectively neck and neck on LLM inference. So they've made a lot of progress in being able to get that scale out for inference. Training is a little bit harder though. And I actually think it's a software ecosystem challenge. So I'm going to tell like a quick anecdote about this. So back in Baidu, we built out some of the first prototypes of distributed training. We actually built the first large-scale CUDA cluster in the world. It was around 1,000 GPUs, and it was the first one ever for deep learning. And so we prototyped a bunch of software on that. And one of the things we typed was distribution strategies and collectives, and then distributed training frameworks that didn't just use async, they used MPI. And the legacy of that is that some of the pieces of that is a lot of that team actually went back and worked at NVIDIA, got integrated into Megatron. So there's now this framework that's developed by NVIDIA engineers, used to be Baidu engineers, of course, a bunch of new contributors too, but it's really a good way of doing distributed training. And it's one of the only good open source frameworks for distributed training that works at that scale. And the problem with it is that it's actually wonderful that it's open source, but because it's NVIDIA developed open source, it's not like PyTorch. It's not owned by a neutral third party. It's owned by, NVIDIA, who has even if there's some altruistic nature of making things open source, there's not really a strong motivation to fix bugs or to performance or tune performance for AMD or anyone else. So that's, I think, a big gap in the ecosystem.
This is also another really good point that Jensen is able to really negate. Jensen, if you go and watch, so I'm going to show you the Lisa Su interview with All In, the best podcast in the world, the number one podcast in the world. But if you were to watch the whole video, I'm only going to show you the Lisa Su part. Jensen is the best salesman on the planet. This topic comes up on the podcast, on the interview, and when he's talking with the All In guys, and he makes it seem like open source, like NVIDIA is open source. However, I think when you really look at it, NVIDIA is more akin to Apple, maybe not as much, but and then AMD is more like Android potentially. And there's probably another better analogy for that. But my point is, AMD has drastically changed their software culture over the last year, and it's an incredibly open source platform, really catering towards developers, fixing bugs at light speed. I'm very in tune with Anusha's account on X, and he responds to like every developer that has a problem. Like, it's kind of amazing, and they go and fix it. So I think AMD is a little bit behind right now in software, but the gap is closing, and it's closing at a rate that people aren't aware of, because AMD has the flywheel going. Yeah, I know it's a kind of a word that everybody uses a lot, but the faster you spin that, your improvement rate as it keeps going. If another company or person's learning rate or improvement rate is slower over time, you're going to catch up and surpass them. So I think, and I could be wrong, but I'm going off based of what these super smart engineers are saying. Open source, AMD really has an advantage over time with their open source ROCm stack. So, all right, let them keep talking.
Is that inference is probably completely fine. We have great open source frameworks like SGLang or VLLM in inference that are just fine and they're vendor neutral, but there really isn't like a vendor neutral, good, scaled out training framework.
Mm-hmm. This is a great transition for us to talk about what you're working on with Scalar LM. Maybe you can go into kind of your thought process behind Scalar. What is Scalar LM, and what are some of the things that Scalar LM contribute to helping solve some of these problems?
Yeah, so that's really what we're trying to do, is we're trying to just create a Megatron inspired, because they got a lot of the right software design issues.
Okay, I think the rest is very technical, which is great stuff, but I know even me, I work in a technical industry and my eyes start glazing over here. So, all right, let's move on to the interview with Lisa Su, and the number one in podcasts in the world.
Okay. Hi, Lisa.
Nice to meet you.
Lisa, it's a pleasure.
Hi, nice to meet you. Hi.
Well, thanks so much for being here with us today. We don't have a lot of time, so we want to get into it. In April, it was announced that you achieved your first silicon output at the TSMC facility in Arizona on that 2-nanometer line. This administration and the private sector have talked a lot about onshoring semiconductor manufacturing. Would love your thoughts of the on-the-ground experience in Arizona. How's it going? What's not going well? What does America need to do to get this right?
Well, absolutely. First of all, it's a pleasure to be here. Love the theme. I think we're all super excited about winning the U.S. AI race. And I thought if we're going to talk about chips, David, I should actually bring one.
Oh, awesome.
If that's okay?
Oh, yeah.
A little bit of show and tell. So this is our latest generation AI chip. It's our MI355 chip, 185 billion transistors. Takes about 9 months to build. Lots of technology on it. If I just...
Is that 2 nanometer?
This is 3 nanometer and 6 nanometer. So lots of different chips.
Just a quick interjection here. The MI355 is 3 nanometer. However, AMD is building a 2 nanometer chip with TSMC here in America. And she talks about that a little bit here. But they're one of the first to be doing that. So they're really going after that next level chip.
Putting this on eBay later.
I'm going to take it with me whenever. How's that?
Thank you.
But look, to answer your question, I think these AI chips are extremely, extremely complex. They have so much technology on it. We're super excited about the progress in U.S. manufacturing. I would say, 12 months ago, people weren't sure that we could do leading edge manufacturing in the United States. We've been very early in Arizona with TSMC, and we did get our first chips out. They're actually 4 nanometer. But what we see from it is where there's a will, there's a way. And I think all of the conversation about onshoring manufacturing has been super good for the semiconductor industry, and frankly for all of us in semiconductors. We're in such an interesting place because chips are so essential to ensuring that we are able to win the AI race, that we want to make sure that there's a lot of geographic diversity and capability there.
But the reports out were that TSMC couldn't get good qualified, trained employees. They had to bring folks over. Is that accurate? And again, if we're going to scale, what's the order of magnitude we're going from here? Is it 10x, 100x? And how are we going to build a workforce to support this industry, which is a completely new industry for America?
And Lisa, you have permission to speak freely.
Yeah.
The best way to say it is, no matter when you start something new, it's going to take work, right? It's going to be hard. So sure, in the beginning, there were some issues of,
Lisa is like the preeminent CEO when it comes to class and responding with very good and professional responses. So you may not always get a super, it's the opposite. I wouldn't say it's disingenuous. Actually, she just states what she believes, but she does it in a way where she's not going to polarize anyone, which, if you talk about other CEOs, maybe Elon Musk or someone like that, she's always classy. She's never going to really give you an answer that's gonna be a clip that you show on mainstream media for views. And I don't mean that in a bad way. I actually think And I'm going to create a different video about this that I've been wanting to create for a few weeks that goes in depth about Lisa Su's leadership style that is actually backed in deep research by Jim Collins at Stanford. And I'll go into that more, but I just wanted to say that.
TSMC has like a formula for how they build, and they just rinse and repeat, and they've learned how to do that well in Taiwan. So they had to learn how to do it well in the United States. But I have to tell you, we've been super impressed with the progress. And if we look at the main thing that we look at is yields and just how many chips do we get out on a given wafer. And I would say it's equivalent between what we get in Taiwan and what we get
cost?
in Arizona.
Because it's unrealistic to think the United States could compete on cost. Am I correct?
We're going to pay a little bit more.
Give us the ballpark. 50% more, 20%?
Not 50% more. I mean, look, it's going to be more than 5%, but let's call it less than 20%.
So low
double. Let's say low double digits.
And how does that impact the business, if at all, in terms of competition globally?
Well, I think the important thing is, just think about everybody wants a GPU, right? If you look across the industry, you really.
Okay, I'll put important point here, and I think there's actually a few points to make. The new TSMC fab factory in Arizona is up. They're producing. They're going to keep producing, but it costs a little bit more right now for them to make the chips, and there's probably many different reasons for that. Higher salaries in the US, higher costs potentially, but I think this also has something to do with scale. So over time you may see the costs of these fabs here in the US with TSMC go down. And I think in relation to AMD and AMD investors, I think this means that when you see them sell off a piece of their business like ZT Systems manufacturing, I think that's them preparing for these increased costs. They want to maintain or boost their gross margins. So if you're going more asset light, really going all in on chip design, you want to increase your margins as much as possible. So this is going to help AMD's margins overall, but it's also going to mitigate maybe some of the cost impacts from the new American TSMC fab. So I was thinking about this earlier on a long walk, and I could be wrong on that, but that's my take on that.
Really say, the people who are going to win in AI want to have as much compute in their foundation as possible, and they want assurance of supply. We want to be able to supply this no matter what happens. And so if you put that in context, the fact that you're not going for the lowest cost, every minute of the day, is okay. It's okay. Obviously, we're not going to build. Not everything needs to be in the most advanced technologies, and so we have a very geographically diverse supply chain. I think Taiwan continues to be important in that view, but the focus from this administration on getting onshore manufacturing in a big way, not in a small way, I think is very good for the country.
How much time do we have if there was a disruption for whatever reason? We can come up with hypotheticals in Taiwan, and we were unable to get chips from those factories. What would that look like globally?
Yeah, you have to look across the supply chain, but from a structure standpoint, we all want to keep reserves for those times, but it's months, it's not years.
Lisa, there was two really interesting posts over the last couple of days. One was from Elon, where he said in 5 years he projected 50 million H100 equivalents just for XAI. And the second was Sam Altman. They signed a deal for a 4 gigawatt data center, 30 billion a year with Oracle. That just portends an enormous amount of chips that are necessary and power.
And to Chamath's point, all three of the companies he just mentioned are AMD customers. Now, a year or two ago, were these three companies big AMD customers? For CPUs, maybe, but not really. We're talking GPUs now, and obviously with AMD's chiplet platform, you're getting that CPU as well. But here's my point. Oracle has a huge deal with AMD to build out data centers. They're not just building out data centers with NVIDIA products at Oracle. I think it was a 30,000 plus AMD deal that they did for the MI355, but I think they may have increased it, and I'll have to find that information for you guys, but I'm pretty sure it's much larger now. OpenAI, Sam Altman made a surprise appearance at the AI Day last month. and OpenAI is helping Lisa and the AMD team develop their next generation GPUs. So they're helping them develop that. And then Tesla is also a big AMD customer in several different ways. I own a Tesla. My Model 3 from 2023, it's the AI3 product, has an AMD Ryzen chip in it. But now Tesla's also buying their GPUs. So the reason this is important is because Chamath is making the point that one of the ways, and there's many ways to solve this AGI, ASI problem, where how do you make intelligence so good and so cheap? Well, you have to spend one of the ways is you spend a lot of money on compute to get this problem solved, but then over time through Moore's law you make it cheaper and better. So what that means for chip investors, for semiconductor investors, is that we're really still at the beginning of this semiconductor AI wave. And you may see some blips or, downward trends here and there, but unless something changes dramatically, you're going to continue to see Moore's law bring the cost of these chips down, which will increase demand. But with the cost going down, you also see the performance going up, which will increase revenues and productivity. So it's a double whammy for demand. And companies and countries are all wanting to make their own AI, and they're all wanting to develop AI and do all these different things. So we're really still in the early stages. And I think, I think Chamath makes a good point here.
And if you forecast that, how do we actually meet all of that? What needs to happen that's not happening today inside of the United States to actually do that?
Yeah, it's a great point. I mean, that's what we're seeing. We're seeing this incredibly large demand for AI, and they're coming from, Sam and Elon are certainly the leaders, a couple of the leaders. There's a lot of demand elsewhere too. I mean, if you think about it, nations want their own AI. So there's very high demand. We're imagining that just the accelerator market, so the chips for these AI large computing systems will be like, over $500 billion in a couple of years. So very high growth. And when you say, what do we need to do? It's the entire ecosystem needs to scale up. So we need to scale up. Certainly what we're doing in chip design is trying to get chips out as fast as possible, but we're also scaling up the entire manufacturing ecosystem. And, as I said, I think the US is going to be a huge piece of it. So it's not just about the silicon. There's all of the various other pieces of the ecosystem that have to come to the US. Sure. And I think, I think today's AI action plan is actually a really, excellent blueprint.
And how do you see the market evolving in these next 5 or 6 years? Is it there's a standard set of chips for training, a standard set for inference, or do you just see an explosion, like a Cambrian explosion of different ASICs, different designs, different use cases?
Yeah, I like that question because I am a believer in there will be diversity of chips. And the reason is there's so many use cases, right? If you think about use cases from, whether you're talking about science or manufacturing or design or back end or, frankly, personal AI, I think we're going to see AI in everything that we do, certainly in your phones and your PCs. And so you have all these pieces. You're going to have different types of chips that do that. Certainly for the largest systems, we tend to believe that you need the most compute you can get, and so GPUs are there, but lots of ASICs are in the process, and we'll see a variety of different chips.
You opened up a really interesting line of questioning there. When mainframes were so expensive, and then eventually wound up having PCs that were more expensive on their desktop, you alluded to AI being run locally.
Yes.
When would we have a local computer, a laptop, a desktop computer that would have the power we're seeing to run some of these LLM models in your mind? And do you see that as a specific market to go after?
Look, I definitely see the idea that AI will be at every part of our ecosystem is a real thing. I think that's one of the advantages. If you think about the power of AI, you want it everywhere, and you want it across all different applications. And I think when you think about PCs today, we're putting significant amount of AI in them to run local models. And why would you want that? It's like, well, maybe I don't want all of my personal data, all over the place.
On that point, can you make a prediction on when the market for physical AI chips is greater than the market for chips and data centers?
I'm going to pause on that note by Lisa. It's like, oh, maybe I don't want to have all my personal data, exposed to these large clusters. So that's extremely important because we don't want we want to have a democratized AI situation where the individual is really empowered. And, I have a whole nother video planned on this that is completely separate. Really, it goes into the lore of Halo universe and how AI is developed in the Halo video game universe. Anyways, my point is we want the individual to be empowered by this technology, and AMD wants to power that. And they're working with many different customers to do that, but one that sticks out is Tinybox, with George Hotz, who for a long time was one of AMD's biggest detractors. But as soon as he saw AMD start to change their software philosophy, their software culture at AMD, he invested $250,000 into AMD back, I think it was, when around $100 or so, in that range. So my point with that is George wants to do that same thing. And they're partners, pseudo customers of each other. I think Tinybox, Tinygrad is a customer of AMD, not vice versa. But there is really going to be this push over time, and I think this is good because this is what America is about. We don't want AI to kind of be this totalitarian mechanism or technology that looms over everybody's head. We want it to be where it empowers the individual to have their own AI, to learn and to develop products of their own based on their own data over time, and not be just sucked up by these massive companies. So I just wanted to make that point.
That's a great question. I'm a big believer in physical AI. I still think let's call it 5 years.
You think 5 years is that fast?
It's at least 5 years.
So you're saying 5 plus?
5+. Yes.
Yeah. Okay.
But that is ultimately the biggest end market. Do you think physical AI becomes the biggest end market?
I think it becomes a significant end market. I think you look at chips in data centers and you look at chips at the edge, they're also significant markets.
Mm-hmm. When you look at the most cutting edge techniques today, EV lithography, all of this whole stuff to make chips, one of the things that's observable is we're only as good as what humans have been able to invent. And I often ask the recursive question, what happens when the AI is able to invent its own method of manufacturing? Different material sciences, different approaches that we may not necessarily understand. Is any of that R&D happening, whether in AMD or in other places? Like, how are we trying to get beyond the physical limits of electrons shunting across a junction?
I think this idea that the AI can be extremely smart and extremely capable, like we think about how AI can design the future chips, and it will design pieces of it, but there's still a creativity of bringing it all together that I think humans are still absolutely at the center of that. So I don't necessarily see the AI designing our next generation GPU,
right.
But I do see it helping us design the next generation GPU much faster and more reliably. So
you talked about the need to reshore more parts of the ecosystem. Obviously, you guys are world-class chip design. The fabs are getting reshored. But how do you think about things like lithography? Does that need to be sort of reshored, or does ASML need to start building sort of machines in the United States, or is it okay to have that type of supply chain risk on an ally?
Look, I think we have to accept the fact that it's a global supply chain. Like, even if you were to reshore, X number of components, you would still have Y components that are across the world. I think it's important for us to have our allies together. So that's a key piece of the conversation, and ensuring that, we have access to the latest generation technologies, and that is, something that we protect given our intellectual property.
And going to first principles and asking you the open-ended question, what should be done about American education? I'm going to ask this a lot today. Assume there's no college, high school, nothing. You arrive in America, the situation is what it is today. What do you do? How do you build an education system to prepare the next generation for the evolving workforce?
Yeah, I'm probably a little bit biased, as maybe some of your guests are today. I'm a big believer in science and technology background as being, sort of the STEM background is so helpful when we think about the future workforce. And the earlier we can get into the sort of the process, I think the better. So some of the work that's being done to kind of revitalize the curriculum, I think is pretty important in the sort of the next generation workforce. And one of the things when I think about how we win in AI, there's so many aspects of it, but ensuring that America is the best place for AI talent is also a key piece of that. So kind of inspiring people when they're young to really study science and technology.
So when you go to bed at night and you think about the best case scenario for this technology and this trajectory we're on, which is accelerating and you're enabling, what could the world look like in 10 years? Let's say, pretty obvious we're hitting artificial general intelligence at this moment. I think we'd all agree we're starting to see that. But super intelligence can't be far behind that. I assume you agree with that. Soon we hit that super intelligence. What will the world look like in 10 years in the most optimistic scenario if we do this right?
Well, I think the exciting part about it, and I can say this very sincerely, I mean, this is the most transformational technology sort of in our lifetimes. I mean, that's the way we should think about
Orders
AI.
of magnitude.
Orders of magnitude. And the reason is it's not just going after one aspect, right? You can actually take AI and make science better. You can take AI and make medicine better. You can take AI and make manufacturing better. You can take AI and make every aspect of your business better. And so, in my mind, 10 years from now, we'd like to believe that we are really leveraging it to solve some of the world's most important problems. I like to say, AMDers get up in the morning and they say, how can I use technology to solve some of the most important challenges in the world? And, AI is really our mechanism for doing that.
I have a business strategy question. If we went back 20 years and we wrote the tale of three companies, NVIDIA, AMD, Intel, and then you fast forward to 20 years, two have just absolutely thrived.
I have more on this too. There is a deep rabbit hole to go down in the semiconductor history. So like the history of chips, you go all the way back 1930s or 40s, and then you go into Texas Instruments, you go into Intel, TSMC. There is quite an amazing story that when I started learning about it, and then I also listened to one of the acquired podcasts about TSMC, it just kind of opens your eyes a little bit. And it really talks about how these, you've seen the rise and fall of these different semiconductor companies. And Intel is basically the best example of that, where they had a monopoly. Then TSMC came along, and all the Intel customers were desperate. They were extremely desperate for another fab producer. And they got it in TSMC. And TSMC was really sitting on their hands. And the reason they're at where they're at now, and their stock has gone up 1 or 2 or 3% over the last 20 plus years, is because they kind of slowed down on the treadmill, and TSMC has been sprinting since the 1990s. So there's TSMC just really is constantly innovating, and that's why TSMC is now the dominating fab company, and arguably a monopoly. And one of the things I thought about here is, I was like, oh, well, and I'm not saying that NVIDIA is going to be the next Intel. I actually think the opposite. I think NVIDIA will continue to be the dominant player. However, the story of Intel and the story of Intel and TSMC is illuminating in the story of AMD and NVIDIA. NVIDIA, everyone loves NVIDIA products. It doesn't mean that they're not desperate to have another key player in the market to decrease costs and, keep competition high. And sure, there is a ton of competition in semiconductors, like a ton of competition. But I guarantee NVIDIA customers are desperate for AMD and others to do well. And this creates this kind of dynamic where if NVIDIA slows down or kind of missteps in any way, they could fall behind on the semiconductor treadmill, where there's a quote from Miles Chang, the CEO or chairman of TSMC. If you fall behind at all on the semiconductor treadmill, you might as well have just fallen off, which is what happened to Intel. So this really means that AMD and these other semiconductor companies, Broadcom, they don't have to kill it to do extremely well. There's a huge market for chips. So AMD could overtake NVIDIA, or it could just increase market share to 10% or 20% and do fine, like do more than fine. So it's a very interesting dynamic, and I'll try to write up something on that Acquired podcast at some point. And if I don't, go and listen to that podcast. You'll learn so much about semiconductors.
And one has not. And if you had made the bet back then, it would have been very inconclusive that you would have picked NVIDIA and AMD. And if anything, there was an amount of inherent belief that Intel had just figured it all out. Can you just tell us sort of like the lessons learned of why you've thrived and maybe what you take away from their journey that you make sure AMD doesn't play out?
Well, as a CEO, we have to be paranoid every single day, right? So we don't rely on the past, but I think there are lessons of the past. And I think that probably the most important lesson that I can say for technology is you have to shoot ahead of the duck. Like you have to be thinking, what is the most, like your question, Jason, great question. We think about that all the time. How do we shoot ahead of the duck? And, you have things that change. Technology is a beautiful place because you see big inflection points. Like 5 years ago, AI was around, but we wouldn't be able to gather this audience to talk about AI because people would be like, who cares? But the fact is you had to invest many, many years ago to be where we are today. And I think, I like to say that, you will be able to judge whether we've done a good job or not by how we perform 5 years from now. Like the decisions we're making will take, 5+ years to play out. But that's a key thing in tech. Like nothing is fast, but hopefully it's quite lasting in what it can achieve.
What do you think is happening in countries not in the United States? Like what do you think is happening in chip design and all of these capabilities in China and other places right now?
We should believe that it's super, super competitive. I mean, at the end of the day, I think the world has recognized that that semiconductors and chips are essential. They're essential to national economies. They're essential to national security. And so assume that everyone's investing. I'd like to believe that we have a great head start, because of the innovation pipeline, because of, the great companies that we have here. But we should not be, confused that everybody's investing, and we need to keep up our investments as well. And I think that's why, this whole idea of any one company can provide every solution that's necessary just isn't the case, right? I love the idea of open ecosystems, of companies collaborating, of collaboration across the ecosystem. So hardware, software, systems, collaboration across public-private partnerships, because that's what it's going to take. Like for us to win, we have to be, front-facing and realizing that bringing the countries that win bring all of the smartest people and the best, capabilities together and let them go as fast as they possibly can.
Great. Well,
Really.
Lisa, thank you for being with us.
Wonderful.
This afternoon.
Yeah.
Great. Appreciate it.
Thank you. Thank you.
Okay, that was really a nice surprise to get to hear Lisa talk. I had no idea she was going to be speaking at this All-In Summit interview fest. So the fact that she's on the #1 podcast in the world, or let's call it the #1 podcast in the universe, it's pretty incredible. We don't get to see Lisa speak too often, and I am stoked about the upcoming earnings call. Obviously, I'm biased because I'm an investor, but I believe they'll double beat. They'll probably be closer to $8 billion in revenue than people think, and their guidance, I think, is really going to surprise people. I've been saying that for a while too. So I'm trying to make more videos. This is something I'm really starting to enjoy. Investing is something I'm really passionate about. Like I spend a lot of time at it. Feels like it comes more naturally to me than a lot of different things. But I also have a full-time job. I'm a network and systems engineer. So, it doesn't require a ton of my time. As you can tell if you follow me on X. Like I'm on X all the time. But I'm trying to figure out ways that I can start compounding my content creation and do more of this to really start thinking, talking out loud to myself, which helps me learn, but also maybe getting some more ideas that I'm thinking out to others so they can start to think about them. Is this right? Is this wrong? So they can challenge my ideas. I really want to start doing this more. And I find it challenging Monday through Friday to do it more, but I'm trying. So hopefully I'll be able to start getting more stuff out. Thanks for watching if you made it this far, and have a good week. Talk soon.